Good day, students. Welcome to chemistry class. And today we want to discuss acid, base, and salts. I believe you must have heard of the word an acid. So I want to start by defining acids. What is an acid? An acid is a substance which dissolves in water to produce hydrogen ion as the only positive ion. I repeat, an acid is a substance which dissolves in water to produce hydrogen ion as the only positive ion. Now, look at the definition. An acid is defined as a substance which dissolves in water to produce hydrogen ion as the only positive ion. As the only positive ion. Now, what do we mean here? That what makes a substance an acid is presence of ionizable hydrogen. Not just every hydrogen, but ionizable. Let us take a look at examples of an acid. Examples of acids. Tetraoxo sulfate 6 acid, which is H2SO4. Now, let us see what we mean by ionizing or dissolving in water to produce hydrogen ion as the only positive ion. Look at this H2SO4, which is tetraoxo 6 acid. Now, I have it to ionize. If I put water in this acid, it will have to separate to form hydrogen ion and SO4 minus, which is tetraoxo sulfate 6 ion. That is negative. Now we balance it to have here we have 2 atoms of hydrogen, then we should also have 2 here. Hope that is clear. Now, if you look at this equation, you discover that at the right hand side, we have only but one positive ion. What is that one positive ion? Hydrogen ion. That is why our definition says that substance which dissolves in water to produce only hydrogen ion as the only positive ion. Now, another example of an acid, we have trioxonitrate acid, trioxonitrate 5 acids, which is what? HNO3. Let us ionize HNO3. If we do that, we have HNO3 ionizing to give us H plus and what? NO3 minus. Check whether it is balanced or not. Don't forget, this is aqueous, this is aqueous, and this is also aqueous. Likewise, this aqueous and aqueous. I think this is balanced. Okay, let us look at another example of an acid before we go into the classes of acids. Trioxocarbonate 4 acid, which is H2CO3. H2CO3. Now let us ionize this. We have H2CO3. When it ionizes partially. It ionizes partially to give H plus and CO3 2 minus. You check the balancing. We have 2 atoms of iron here, which does have 2 here. Now, if you compare the ionization of H2SO4, HNO3, and ionization of H2CO3, you discover that the arrow we have here is just single, while the arrow we have here, we have 2 arrows. The forward arrow and the backward arrow. This arrow shows partial ionization, which is partial dissolution. It did not dissolve completely in water. This kind of acid that do not ionize completely in water are called what? They are known as weak acids. Those that ionize completely in water are known as strong acids. I repeat, there are 2 acids based on their ionization ability. There are acids that ionize completely in water. There are acids that ionize partially in water. Those that ionize completely in water are called strong acids. Those that ionize completely in water are called strong acids. Now, let us take a look at strong acids. Strong acids. Examples of strong acids include H2SO4, which is tetraoxosulfate 6 acid. It ionizes complete water to produce hydrogen ion as the only positive ion. What shows you that it ionized completely water? If you check this arrow here, you see that we just have 1 arrow facing the right side of the equation. Now let us look at another example. HNO3 is also a strong acid. We have it ionizes to have this and NO3 minus. Another example is hydrochloric acid, which ionizes to give H plus and Cl minus. These are examples of strong acids. We also have other ones like hydrobromic acid. It is also a strong acid, though it is not that common. So we look at the other one that we call weak acids. Weak acids. Don't forget, weak acids are acids that ionize partially in water, that dissolve partially in water. How do we show that they ionize partially? Look at it by the equation that we give here. By the equation here, we have triazo carbonate 4 acid, which is H2CO3. When it ionizes, it gives us H plus and CO3 2 minus. You balance it to have this. You look at another one that we call hydrofluoric acid. When it ionizes, it has this plus F. Then we look at another one, tetraoxo phosphate 5 acid. it ionizes to give us this. And so on the balance sheet here, you have 3 hydrogen ions. Then here you also have 3 hydrogens. That is the balancing. So the only way you are to show that this acid ionized partially in water is by using these reversible arrows, which we have the forward one and the backward arrow. Okay. Now we have other examples like ethanoic acid. Ethanoic acid is an organic acid, of course. We shall get there. Ethanoic acid, which is CH3COOH. So this ethanoic acid, let us ionize it to see what we have. To give us hydrogen ion. The only ionizable hydrogen present in this ethanoic acid is this last hydrogen. So here we ionize to have this CH3COO minus. Check whether it is balanced or not. It is balanced. Okay. So these are examples of weak acids. One more thing about weak acids is this. When they are ionizing, they try to attain equilibrium. The system involved in their ionization give rise to a system in equilibrium, which means that their occurrence normally takes place in a closed system. Alright, let us look at this. The classes of acids. The classes of acids. How many classes of acids do we have? We have only about 2 classes of acids. What are the 2? We have organic acids and we have inorganic acids. Organic. There are 2 classes of acids. There are organic acids and inorganic acids. Now, what are organic acids? These are acids obtained from the products of plants and animals. I repeat, organic acids are those acids obtained from the products of plants and animals. Okay, let us look at examples of organic acids, e.g., ethanoic acid, where is it obtained from? It is obtained from vinegar, citric acid. Where is it obtained from? It is obtained from citrus, of which the example is an orange. Lactic acid. Where is it obtained from? It is obtained from milk. We shall have a table containing all these things. Let's first of all look at examples of organic acids. We also have fatty acids obtained from fats, etc. Okay. Okay, now I repeat. Where are we? Where do we get this from? We get it from from vinegar. Where do we get this from? From orange. Where do we get this from? Milk. Where do we get fatty acid from? We get it from fats. Fats. We also have other examples like amino acids, which we obtain from where? From protein. Now let us look at inorganic acids. These are acids that are mainly prepared in in the laboratory, in laboratories. In other words, they are known as they are known as mineral acids. Examples of mineral acids include tetraoxosulfuric acids, triazine acids, hydrochloric acids, HCl, hydrofluoric acid, hydrobromic acids, hydrogen, diazide 4, etc. We have many examples of mineral acids. Okay, let us quickly look at the properties of acids. In the properties of acids, we look at the physical properties and we look at the chemical properties. So let's start with the physical properties of acids. Physical properties of acids. Physical properties of acids. The first, because acid turns blue, litmus red. Acid has sour taste. It has sour taste. Concentrated acid are corrosive. Let me explain something there. Acid turns blue litmus red. Litmus is an indicator because it's a paper that if you put it in acid, if you have the blue, have the red. If you put the blue one in acid, it will turn to red. Then if okay, it has sour taste. There are fruit that you discover that they are sour. If you are eating it, you discover that they have sour taste. Let me give you an example. The sour taste of ripe oranges is due to the content of acid. The sour taste of some of these pineapples is due to the content or the presence of acid in them. So acids, they have sour taste. I didn't say you should go and start tasting acid before you die. Concentrated acids are corrosive. When we say that they are corrosive, which means they are highly reactive. They can attack any substance that you try to pour it on. That is, for example, if you should apply acid like H2SO4 on the tiles, you discover that it bleaches the tile within just a few minutes. That is to show that it is very corrosive. I mean the concentrated one. That will take us to the word concentrated. There are some acids that are not concentrated. There are some acids that are concentrated, which means you have dilute acids, we have concentrated acids. When is an acid said to be concentrated? When it contains larger volume of acids or amount of acids relative to the volume of water. I repeat, when an acid contains larger volume of water of acids relative to the volume of water. Let me make it clearer. When there is higher volume of acids than the water you are dissolving it in, what you are forming is concentrated acid. Such acid, you don't touch it because it can affect your skin. It can cause skin burn, it can do anything. They are different from raw acids. They are not raw acids. They are just concentrated acids. They contain small amount of water, relative to the amount of the acid. Now, we have dilute acids. Dilute acids are opposite of concentrated acids. Dilute acids are acids that contain larger volume of water relative to the volume of acid dissolved in the water. I repeat, dilute acids are acids that contain larger volume of water relative to the volume of water it is. Larger volume of water relative to the acid dissolved in the water. That is, when an acid contains much more water than the acid itself. In such a manner, somebody can mistakenly pour it on that person and it will not do anything. Just feel scratches, maybe. You just feel, oh, you poured me acid. But it will not do anything. It will not cause much harm or much burns to your skin. I didn't say you should start, you should do it or try it anywhere or anytime. Okay. Now, there is another thing very, very important. If you are in the laboratory and you want to practice some of these things we are saying here, remember that you don't add water to acids. Instead, you add acid to water. Is a very big precautionary measure that is very important to be taken anytime you are trying to carry out any experiment that involves acid in the laboratory. Now, what will it cause if you do that? It will it will splatter all over the surface of the particular place you are carrying out experiments. And you may be very unfortunate to have it all over your face. You know what that means. your face will be disfigured. So don't try adding water to acid. Instead, add acid to water. Okay, we look at the chemical properties of acids. Chemical properties of acids. Chemical properties of acids. Chemical properties of acids. Okay, what are the chemical properties of acids? The first one, let us list all of them first before we go into explanation. The first one is reaction with highly electropositive metals. Electropositive metals to liberate hydrogen gas. Okay? Then two, reaction with basis slash alkali. Okay? The third one says reaction with triazo carbonates for salts. Triazo carbonate four salts to, sorry, let me clean here so that you'll be able to see words and write word. Reaction with trioxo carbonate four salts to form salts, water, that is H2O, and carbon 4 oxide, CO2. I believe you know that. Yes. Okay. Now let us explain them one by one. I hope you are with me. Good. Reaction with highly electropositive metals to liberate hydrogen gas. Highly electropositive metals. When we discussed the elements, we gave you metals in electropositivity series, which include potassium, calcium, and so other ones. Potassium, calcium, sodium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. So all these things are the metals electropositivity series. But there are ones that are higher than hydrogen there. Let me just take a look at something. We have, okay, we have potassium, sodium, magnesium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. Thank you, God bless you. You are there, you are getting it. Okay, now here we have potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen. So from here up, check, these are the metals in electropositivity series from here up can react with acids to liberate hydrogen. Okay, but there is something very important. Let us illustrate it so that you'll be able to get what we are saying. Sorry, I believe you must have noted these ones. Okay, reaction with metals. Let us look at potassium. Potassium reacting with H2SO4 to give us potassium tetraoxo sulfate 6 plus hydrogen. You look at this reaction here. You see, the reaction here, potassium is metallic, which is solid. This is aqueous to form these salts and liberate hydrogen. Now, you see that what simply happened here is that this potassium being stronger than this hydrogen here simply displaced Mr. Hydrogen. If you look at the right hand side of the equation, you discover that instead of having hydrogen here, what do we have? Potassium has taken the position of hydrogen as it was in the beginning of the reaction at the left hand side. Okay? Let's just give another example of an equation justifying the reaction. Maybe let's look at calcium, metallic calcium, reacting with hydrochloric acid to give us calcium fluoride, liberating hydrogen gas. Are we together? Yes. Okay. Make sure it's balanced. Find out. I don't think that this one is balanced. The first one is not balanced. You check it. Check the second one. Have two potassiums here. Have two potassiums. Two hydrogens. One sulfur, one sulfur. Four oxygens. Remember, it is an abomination to write unbalanced chemical equation. Don't try doing that. Okay. Then we come to calcium and hydrochloric acid. We will see here calcium chloride plus hydrogen gas. Okay, now there is something you must note down. What is that? We have many acids, of course, like I gave to you. It's not all the acids that can undergo this type of reactions to liberate hydrogen gas. Trioxohydrified acid is exempted from this reaction. Why? It is a very strong oxidizing acid. It has strong oxidizing tendency or ability. If it should react with any acid or any metal, it will go on to start oxidizing the metal instead of liberating hydrogen. Okay. Then we quickly look at, don't forget this point please. It's very, very important in case you come across it in objective or in any of your external exams. Even in your internal exams, of course, it's possible. Why is trioxohydrified acid exempted from the reaction between metals and acids? Because it is a strong oxidizing agent. It is a very strong oxidizing agent. Okay. Now, the second one says reaction with base or alkali. Bases, we have bases that we shall still talk about bases. So, what are bases? Bases are simply oxides or hydroxides of metals, which reacts with acids to form salts and water only. I repeat. Bases are the oxides or hydroxides of metals, which react with acids to form salt and water only. So as the case may be here, we have reaction with acids to form reaction with bases to form salt and water only. Or we said bases or alkali. Alkali are simply the hydroxides of metals. Hydroxides of metals. Like we have NaOH. What is the sign of the presence of this hydroxide? Presence of OH. Any compound that contains OH contains hydroxide. Then any compound that contains O and a metal only contains oxide. So this is oxide, this is hydroxide. Have you seen the difference here? This is a base, this is an alkali, this is a base. This is also a base, just like this one. But this one is partially soluble. A partially soluble base. That's what we call it alkali. Alkali. Likewise, many others, I believe we get to that, like sodium oxide is just a base, sodium hydroxide is an alkali because it is a soluble base. All the soluble hydroxides of metals are called alkali. We shall get there when we get to this. Okay, now, reaction between acids and what? Bases. Let us look at this calcium oxide reacting with any acid. Let me first write acid. Let us use HCl plus calcium oxide. This is solid, this is aqueous. Of course, calcium oxide is quick lime, quick lime. Then we have the product to be here. Check the series I gave to you before. We have calcium here, we have this hydrogen here. Which one is higher? I think calcium is higher. So let me first write down calcium. Okay, what will calcium simply do to come and push this man away from here? Mr. Man, just leave this place, find a way. Okay, then we have CaCl2. And many people will be asking, why does Cl2? Let me just give you something here. This reaction is something from here. Of course, reacting with HCl, Cl minus. Cl minus, of course. Chlorine atom having 17 electrons, of course, has 2, 8, 7. It needs one to complete itself octet, to complete the valence shell, to make itself octet. So when it receives that one, it changes from being 287 to being 288. It remains the same chlorine, but the chlorine it will be now the Cl minus, and no longer chlorine atom. So the difference between this and this is that this is chlorine atom, this one is chlorine ion. So this is the one that we have here. So likewise, calcium here, calcium's atomic number is 20, which means it also has 20 electrons, which means 2, 8, 8, 2. So it can easily give out these 2 than receiving, it can easily give out these 2 than receiving 6. So in that case, when it gives out these 2, it becomes 2, 8, 8. It is not owing anybody. It is a giver. And a giver must be a positive man. Is a free man. So far I gave to you, I am a free man. So calcium gave out. It will change from being calcium atom to calcium ion. That is what I have here now. So that is this is how these two things react to form this. So if I come in, I have these are, we call these the valencies or the position numbers. 1 here times by this calcium still give us calcium. Neglect this negative sign. 2 multiplied by chlorine will give us chlorine substitution 2. That is what is here. I believe that is clear. In case it's not clear, you can write us through our channel we'll make it clearer in another video. All right, this is salt plus what? Remember I said to form salt and water. Water is liquid. This is the salt, aqueous. So if you check the balancing, I have two hydrogens here. How many hydrogens do I have here? I have only one, so that's two here. So I have two chlorines here. I also have two chlorines here. How many calciums do I have at this side? I have just one. I also have just one here. I think it's balanced. Okay. Now we can still give another example, like maybe example. Let's use triazo carbonate 4 acids reacting with sodium hydroxide. Okay. The same thing I explained here is what will happen here. Mr. Sodium is higher than this. It will simply come and take over this to form sodium triazocarbonate 4, which is the salt, and we are left with H2 and okay, we are left with H and OH. H and OH, which I have H. Sorry, this cannot work out. This must form water and carbon 4 oxide. Is a triazocarbonate anyway. Let us not use this example so that it will not confuse you. Now let's look at another one, HNO3 plus sodium hydroxide, which is an alkali, to give us sodium. What will happen here? It will just push Mr. Hydrogen away for being stronger than Mr. Hydrogen. To form, okay, we are left with OH, which will give us water. OH and hydrogen here. This is liquid, this is aqueous. Some people may be confused on how this is like this is this, but we have some of them that might be like this. I know. Don't worry, we'll make it clear in time to come. This is just sodium reacting with this radical known as trioxynitrate ion. This multiplied by 2 just give us this. This one multiplied by 2 just give us this. So that is how bad it is. God bless you. Okay. Now, check the balance. Is it balanced? One hydrogen, two hydrogens. Okay, 1 plus 1 give us 2, which is 2 here. We have one sodium here. We have one sodium here. Okay. We have 3 oxygens plus 1 here will give us 4. 3 oxygens. Okay, it's balanced. Okay, it's balanced. So we look at the next one. I think the last chemical property, reaction between acids and triazocarbonate salts. Acids and triazocarbonate salts. How do we know triazocarbonate salts? How do we know that? How do we know that? Because any salt that contains CO3 is a triazocarbonate. They are simply salts formed from this radical triazocarbonate 4 ion, or from hydrogen triazocarbonate 4 ion. Any salt formed from this or this is a triazocarbonate 4 salt. So when we say reaction between acid and triazocarbonate 4 salts, I mean, if I should just have this man here, which is CO3 2 minus, reacting with any metal, of course I should have, okay, let me have this metal first, reacting with this. This will give us 2 here as sodium will give us sodium 2. Then this is 1 multiplied by CO2 will give us CO3. This is a triazocarbonate 4 salt. Don't forget, though we have not done salts, but let me briefly explain what we mean by salt. A salt is a substance formed when part of the ionizable hydrogen is replaced by a metal or ammonium ion, by a metallic or ammonium ion, which is what we have just shown here. H2CO3 is an acid. If I have this one replaced by a metal, like I did here, I will form a salt. We shall get there. Okay, now triazonitrate carbonate phosphate, yeah. I have sodium trioxocarbonate phosphate. Let me write acid first. H2SO4, which is tetraoxosulfuric acid, reacting with sodium trioxocarbonate phosphate to give us, definitely this is 2, okay. This will come and take the equation. I'm going to have sodium tetraoxosulfate 6 salt. Plus, remember I said the product is always a salt, water, and carbon dioxide. Okay, which means I'm left with what? Water. Then the remaining one is what? Carbon dioxide. If you look at it here critically, you discover that once I remove this man, putting it in place of this man here, I'll form this. So I'm left with H2, H2 and CO3, which if I break it down, I have H2O and CO2. Yes, this particular equation now is a very important equation that there are cases we can apply to prepare a new acid. Yeah, we can apply it to prepare a new acid. In such manner, like if we are using it to prepare an acid, we are to write it together, H2CO3. But if it is a reaction between an acid and any of this, we don't write the product as an acid. We write the product as carbon dioxide and water after we have written down the salts formed. I hope that is clear. Okay, thank you. Check the balance with me before I wipe the board. I have two halogens. I have one sulfur here, I have one sulfur. I have 4 oxygens plus 3 will give us 7 oxygens. I have 4 oxygens plus 3 will give us 7 oxygens. And what again I will, no, everything is okay. I think it's balanced. Okay. Then, after this, we look into uses of acids. I don't know, use of acids is important of course, but we're supposed to look at the preparation of acids. How can we prepare acids? It's very, very important. It is very, very important. Okay, uses of acids. Well, what are the uses of acids? Uses of acids. Of course, acids can be used. Can be used to remove rust. Can be used to remove rust. It can also be used for making fertilizers. It can be used as preservatives like ethanoic acids and other ones which you can just go and browse on your own. Thank you for listening. God bless. See you.